In this video, we will discuss derivatives of exponential functions. So if you consider an exponential function with some positive base a, then its derivative is the natural logarithm of the base times the function itself. Now, you can take this base a and represent it as the Euler number e to some power k, in which case we call this power k a continuous growth rate. And of course, we can calculate it just by taking the natural logarithm of the base a. And if you plug in into this first formula, you can rewrite it as the derivative of e to the kx is this continuous growth rate k times the function itself. And so we'll check this formula in the second representation. So to calculate its derivative, we have to take the function at the point x plus h, subtract the function at the point x, divide by this increment h, and then let h go to 0. Now, in the case of the exponential, e to the sum is just the product of exponentials. So we can write it as e to the kx times e to the kh minus e to the kx divided by this increment h. And so you can see that you can factor out this e to the kx, and then you are left with this second factor, which is e to the kh minus 1 divided by h. And we want to know what happens to this factor when h goes to 0. Now, this is one of the famous limits in calculus, and we have already discussed it in one of the previous videos. So we already know that that second factor converges to this continuous growth rate k as h goes to 0. And so you can see that the derivative of this function is exactly the function itself times this continuous growth rate k. And of course, the most famous case of this is when k is equal to 1, and the derivative of e to the x is just e to the x.